move the object, then you can go for the translation. See, when we are just moving the object from one place to another place, we are not only moving the picture, we are just moving each and every pixel, every point, okay, every part of the particular picture or the object from one place to another. That is, we are relocating it. So in this case, I can say that a 2D point P of x comma y, I'm just considering a pixel. Instead of moving an object from one place to another place for just showing you, I'm going to move a pixel, okay, a point from one place to another place. Here I'm considering the old point as P and the new point as P dash. So how we will be moving? So how much distance we are going to move from the old to the new? That distance I'm going to add. Okay, that is called as what? The translation. Translation is adding the old position with the distance so as to get the new position of the object. So this is called as what? The translation. So the translation distances I'm considering as tx and ty. So I can say these are all translation factors. Okay, let's go for the mathematical explanation. So when I'm just considering this translation, okay, so translation, when you see, so translation, this is a xy coordinate, as all we know. A point I'm just going to take, okay, a point I'm going to take. This point I'm considering as P. The new point, the point I'm going to transform from this position to this position, P dash. Okay, the old position I'm considering as x comma y, and the new position I'm considering as x dash comma y dash. Okay, so this is the transformation distance, or I can say the translation distance t. So this can be given as tx comma ty. Okay, so the point is going to move from this place x comma y to the new place x dash comma y dash in the linear position with the translation factors tx and ty. So basically this is additive, right? So the equation can be given as the new position x dash can be given as the old position x plus tx. Tx is the translation distance with respect to the x. Y dash is equal to y plus ty, where ty is the new translation factor which is going to, along the y axis. Okay, so this is actually what this tx and ty. But when you are just moving from this position to this position linearly, the y value is what constant. So ty we won't be giving here. But when you want to move from this position to this position, for example, okay, the new p dash, then in that case you will be moving both x as well as y. So in those cases I will be using these two equations, that is x dash is equal to x plus tx and y dash is equal to y plus ty. So depending upon the movement, either we will be using the x coordinate value or we will be using the y coordinate value. Sometimes one will be constant and another will be moving depending upon the direction. So this is equation format, okay? Equation format we will be using. Sometimes we will be using matrix form also. So the matrix can be given as, the translation matrix can be given as x dash y dash. The new x dash y dash can be given as what? That old value of x and y. I can say that it is tx and ty. Okay, so in this way I can give what this transformation value. Okay, so in this way either I can give this what mathematical equation, or in the form of the matrix I can give. Okay, matrix format. So let's go for the demo. So this is a translation near a C programming environment. Don't worry about all these things. Just see this line equation. Line. Okay. So the line is going to take 4 parameters. Okay. The xn starting value, that is I'm going to move a car from one place to another place. The car is made up of lines and circles. So the lines and circles ready-built functions are available in C language. I'm going to use this line and circle functions. The line is going to take the starting point and the ending point. So 100, 300, 120, 300 is actually what? The starting and the ending point of the line. So when I execute this function, the line will be available in the screen. But plus I, when I'm just using, I is nothing but the translation factor. Here I'm using what? Only the I along only with the X value, X parameter I'm just using. Why? The car is going to move in the X direction from left hand side of the screen to the right hand side of the screen. So the car is made up of several lines and circles. Therefore, I'm including this translation factor I in each and every part of the car. Okay. So let's see how this is going to happen. Let's run the program. See here. So the car is moving, but the circle is not moving. So if you're not clear, I'm just rerunning the program. So the car is moving, but the circle is still not moved. Because if you want to move the circle, so if you want to move the circle is not going to translate. That is, it is not going to move in a straight line path. Instead of that, in the circular path, it is going to move. Therefore, we can go for the next type of transformation called as the rotation. Rotation means in order to reposition the object in a circular path on XY plane, then you can go for the rotation. Here you will be specifying the rotation angle, and previously I have told you for moving forward you will be adding the translation factors, but in order to move backward, then you will be subtracting the translation factor, so that the car will be moved from the right hand side to the left hand side when you subtract the translation factors. So similarly, here the angle of rotation you have to specify by what angle it is going to rotate. Okay, that angle you need to specify. So if you specify the angle in the positive way, then the object will be rotated in the counterclockwise direction, and you will be specifying the negative angle, then it will be moving in the clockwise direction. Okay, clockwise rotation will be done. So all the transformation here with respect to the origin we are going to see. Okay, so let's see this. So now when you see this rotation, yeah, now it is visible, I think. Okay, so this is a point. Okay, this point P, I'm going to rotate with the angle of theta to the new position called as P dash. Okay, the old point P I'm considering as x comma y, and the new point P will be considered, P dash will be considered as x dash and y dash. The already existing angle I'm considering as pi. The new angle what I'm going to rotate here is the theta. Okay, so now I'm just making a right angle triangle from the point. So it's already available in blue color. I'm just reworking onto it. So from this position to this position, new position, I'm going to move with the angle theta. Okay. So again, I'm just giving this in the yellow color, the rectangle, I mean the right angle triangle. So the distance between the origin and this point, I'm considering as R. Okay, now I just want to retrieve this x and y value depending upon this rotation. Okay, as all we know, when you take this right angle triangle, the cos phi will be equal to the base by hypotenuse. So cos phi, when I'm taking for this old x, then it will be what? Base by hypotenuse. The base, this is actually x and this is y. So the base is x and the hypotenuse is r, because that distance what I told is r. So cos pi is equal to x by r. Therefore, what will be the value of the x? X can be given as, already I can say that it is cos phi is equal to x by r. So x can be given as r into cos phi. Okay. Similarly, sin phi, when you observe, it is opposite by hypotenuse. Opposite, when you see, the opposite value was y, right? Okay. This is old value, that is y. So that value was y. So sine phi can be given as y by r because it is opposite by hypotenuse. So y can be given as what? R into sine phi. Okay, right. So let's see to this. The new value x dash. So the old values I have given in the form of an equation, that is x and y. The new value x dash and y dash I just want to retrieve. Okay, the new value x dash can be given as what? Here the old value is r into cos phi. Okay, we are accepting it. Similarly, the new value x dash can be given as r into cos of the old value pi plus the new value theta, because this is the angle of rotation. New angle of rotation I'm going to give here is the theta. Therefore, the new value x dash can be given as r into cos of theta plus the old value pi. Okay, so when this is given, r of, what is cos of a plus b? Cos of a plus b, here it is a formula. Cos of a plus b is equal to cos a cos b minus sin a sin b. Similarly, r of, okay, cos A cos B minus sin A then sin B. So here this R is common for these two terms. So R into cos theta into cos pi minus R into sin theta into sin pi. So what is R cos phi? R cos phi is actually x. Already we derived it. Okay, x is equal to R into cos phi, which is the old value of the x. So R into cos phi is becoming x. So this will become x into cos theta minus R into sin phi will become y. So this will become y into sin theta. So this is the new value of x dash. Okay. Now, similarly, when you derive for this y dash, okay, you will be getting y dash is equal to x into sine theta plus y into cos theta. So expand it in the form of sine of a plus b. So it will become sine a cos b plus cos a sine b. So that you will be getting what? Y dash is equal to x into sine theta plus y into cos theta. Let's go for the matrix format. So similar, in the similar way, that is in the translation, we have derived what? The matrix format. Similarly, here also we are going to derive the matrix format from the equations. So how we'll be getting the new value? The new value can be given as, that is p dash is equal to the old value, and we will be getting. Okay, let's see to it. I'll write it in the matrix format, not in the equation. So this is the old value is x dash y dash can be given as, okay, the equation, when you see, it is x into cos theta minus y into sin theta. What is the coefficient of x? That is cos theta, so it will become cos theta. Then the coefficient of y is minus sin theta, so minus sin theta. Sorry. Then y dash is equal to x into sin theta, so x coefficient is sin theta here and the y's coefficient is cos theta, so cos theta. So these are all the coefficients of x and y. So this is your rotation matrix. Okay, it is in the form of equation as well as in the form of a matrix. So the translation we have derived, we are having only what? The translation factor. So the matrix was not having any other thing other than that tx and ty. But here we are having the coefficients of x and y. Therefore, we have derived what? The matrix for the rotation with the coefficients of x and y. Okay. Now go for the demo. I am having all the programs in one set. Therefore, I'm just commenting the translation program and I'm just enhancing the codes of the rotation. So first you see the thing, then I will explain it. So when you see here, the wheel is actually rotating, right? So what is there in this code? You just leave all those things. Now when you see, these two lines. Each and every pixel of this x and y. Wait a minute. Okay. X plus r into cos theta, y plus r into sin theta. That was the equation we have derived, right? X cos theta, y sin theta. So that cos theta and sin theta here we have with the old value of x we have added, because it is not only rotating, it is also moving. Okay, the wheel is actually not rotating in the same position, it is also translating. When it is translating from one position to another position, then the translation factors we need to add. So when more than one transformation is available, then we can call it as composite transformation. So x into cos theta is the rotation. We have added x quantity along with that, so that the translation is also available here. So x is given, the new value of x is given with the old value of x plus the theta. Theta is set here. Each and every time the angle is rotated for 20 degrees. So the loop will be continuously running for 18 times, and each and every time the wheel will be rotated for 20 degrees. So this what is going to happen here. So this is rotation. And after that we can go for the scaling. Scaling is altering the size of an object and repositioning it. So when you alter the size of the object, automatically what will happen, the object will be repositioned. Okay, so in this case we will be multiplying the coordinate value. In translation we have added, but if you want to resize the object, that is I'm going to enlarge, okay, the object, then we will be multiplying it. If you want to reduce the size, then we can divide the scaling factor. You can use division. So this is actually what the scaling value. So the old value p will be given in the new position p dash by multiplying the scaling factors sx and sy. Let's see the mathematical derivation. So scaling with respect to origin, I already told you x dash is equal to x into sx, y dash is equal to y into sy. So when this sx and sy values, what kind of value we can give? So the values are less than 0. What will happen? The object will be shrinked. That is, the object will become small and will be moved towards the origin. When the value was greater, then the object will be enlarged. Okay, the size will be enlarged and moved away from the origin. When sx is equal to sy is equal to 1, what will happen? So there is no change in the object size, because we are just multiplying. So if you multiply the already existing factor with 1, there is no change. When sx and sy are equal, see, sometimes what will happen, for the shearing transformation and all, we will be giving the sx and sy value differently, so that the object shape will also be altered. But when you give equally, what will happen, that is called as a uniform scaling. When the sx value and sy value are different, then it is considered as a differential scaling. Okay, so when they are equal, it is considered as uniform scaling, else it is considered as differential scaling. Okay, all right, let's go for the demo. Again, I need to block the codes of the rotation. So when you see here, the object size is varying. Before scaling, it was very small, and after scaling, it is becoming so big. So what we did in this code, We have multiplied the scaling factor. So it's only a rectangle. So we have multiplied it. So we have multiplied the scaling factor. The scaling factor here is the I. So we are just giving a value, that is the scaling factor in both x and y, okay, equally. So rectangle, when you just want to enlarge, it will become rectangle when you give equally, or else it will become what, diamond, or diagonally it will be varying. So it won't be like rectangle after scaling when you are just going for a differential scaling. Okay, when the I value is different for x and y value, then it will become some other object. Okay, right. So we have seen what, we have seen our 2D transformations, basic transformations: translation, rotation, and scaling. Translation is basically moving an object from one place to another place linearly. And in that, we are just adding the translation factors tx and ty according to our application. So we have seen how a car is moving along the x direction. And then we have seen what, rotation.